Good evening, everybody. My name is Prerna, and I represent the enterprise team from Cognixia. A very warm welcome to everybody on the session today. I believe many of you have already benefited out of a lot of sessions that have been happening, and I'm happy to see such a huge number of participants that have joined, and the number is continuously increasing. So uh, we're looking forward to a very fruitful conversation and a session today as well. I'll take a quick minute about introducing Cognixia. So Cognixia is a leading digital talent transformation organization, and we have been into the business since more than 5 years now. We, like you are seeing on your screens, we have trained over 130,000 professionals worldwide, and have been delivering in 45 countries over the globe. We have a pool of 7,000 plus industry veterans, which also includes our consultants and subject matter experts. We also cater to 450 plus customers worldwide, which majorly happen to be Fortune 100 and 500 customers. Our forte lies into the digital technologies, wherein we have courses and technologies like machine learning and IoT, AWS, GCP, Azure, those kind of training sessions. Sanjay, if you can take a slide further, please. We can absolutely help our clients with the training modes of virtual, which is definitely happening right now and is the need of the plus. There are sessions that have been happening on the classroom mode too. That's a little about Cognixia. What's in front of you on screen is the various COE that we have an expertise upon, one of which is going to be taking place today, a little in detail. Okay, so our speaker today will be Mr. Sanjay. He has over 11 years of experience into the IT space and has been catering to various organizations for fulfilling their training needs. He also holds a certification from various certifications rather from AWS and Microsoft. I'll hand over the podium to Mr. Sanjay to take up from here.
Hello everyone. I welcome all of you to this online webinar session on AWS Solution Architecting. So, as Prerna said, I have several certifications in IT training. So, I have certification in Microsoft Azure, AWS, Cisco, Y, and CEH. So, without wasting the time, we are going to start our agenda. So, today we are going to discuss about solution architecting on AWS. So, which means the architects who are going to design their environment, their infrastructure on cloud, on AWS cloud. So, how they will design their infrastructure. So, now there are two kinds of users, or you can say engineers, who are working in environment, production environment, or in organization. One is like administrator and one is architect. So, what is the basic difference between admin and architect? So, admin means the person who is going to install, configure, manage, and set up and monitor all the services of your organization. Now, architect means so he has knowledge of setup, installing, configuration, and manage, as well as he know how to plan the project, how to plan, set up, and design the project. So after planning and setup, he will hand over this project to admin team, and then admin will configure all the resources as per the plan, as per the blueprint, which is given by a architect. Now, architect will take care of all the aspects like scalability, reliability, security, everything will be taken care by architect. So that he will design through his experience. Okay, so whatever experience he have in his field, he will design as per his experience, and he will give the best design and architecture to your organization. So we are going to start with, so in this webinar we are going to discuss about basics of cloud, what is the history of AWS, then well architect framework which is designed by AWS, then IAM and VPC. So end of the session, you can ask your queries. If you have any queries, there would be queries from your side. So you can write down your queries into question and answer session or into chat box. So I will be answering to your queries. And end of the session, I will hand over the session to Prerna again. Now, let's start with the history of AWS. how AWS come in the picture. So in 2000, Amazon.com is launched. So they launched their e-commerce website, which is Amazon.com, for in public environment. So when they launched this web application, this e-commerce website, so they were facing few issues. So these issues on the side of high availability and their scaling efficiency, on the basis of their scaling efficiency, because they don't have that much of infrastructure to scale or to manage their traffic, the traffic which they are getting from globe. Now, to overcome this problem, why they are getting this issue is because of their improper planning, and the resources and the services which are hosted, so they all are not separated from each other. So that was the reason. So their complex designing. So the solution was their technician, their IT engineers, they come up with a solution which is a set of well documented APIs. Through that, they are driving their infrastructure. So they come up with this solution at that time. Now, after this solution, they are getting a few issues in their existing environment, like the resources which they are going to use, and the database compute storage which they are going to use. It will take to 3 months to build their environment. And again, there was no planning for those infrastructure, those resources, for in terms of scaling, in terms of reusability. The resources which they are going to use, they are not able to use most of the resources at that time. So after then, they come up with the solution, like the resources, the infrastructure which they have, the data center resources which they have, they are they want to sell their resources in terms of service. So they come up with the solution like cloud computing. Okay, so they are going to sell their infrastructure in terms of services, and at that time, AWS come in the picture in 2006. They started their resources to sell as a service. So now that is all about the history of AWS, how AWS come in the picture, how it is evolved. Now let's talk about the basic of cloud computing. What is cloud computing? So I hope you all right now nowadays you all heard about the cloud computing part in your day-to-day life, and we all are using mostly softwares and tools. Okay, and right now I hope we all are aware about those tools, like we are using Google Docs, we are using OneDrive, we are using Google Drive. So these all are a cloud tool. So which we are using nowadays. We are using iCloud, which is also a cloud storage, where we are storing our content, our contacts, our movies, our videos, our images, so that we can retrieve those through cloud. So again, if we have to define what is cloud, what is cloud computing, so we can define in one sentence, like if we are going to access any IT service through internet, that is called cloud, and we have to pay for that service, that is called cloud. Now cloud means the resources which would be programmable, dynamic abilities. That means you can anytime scale up, scale down, and for those resources you have to pay. That means the resources would be metered. Whatever resource you will use right now in market, if we talk about top cloud providers, so AWS is in top in the picture. Then we have Azure, and we have Google Cloud. So they all are selling their services in terms of cloud. So whatever cloud provider or whatever platform you are using for your infrastructure, you have to pay for the services which you are using. All services will be metered. Now we have 6 advantages in cloud computing. If you're going to use cloud computing, so we have 6 advantages. Now what are the advantages? Trade capital expense for variable expenses, benefit of massive economic of scale, stop guessing your capacity, increase speed and agility, focus on what matters, and go globe in 1 minute. Now there are two terms, capex and opex. Now what is capex? Capex means capital expenditure. So let's suppose if you have a project, or your organization got a new project and they have to build their infrastructure. So first of all, they will plan for their infrastructure. Then they will purchase the hardware. They will set up their infrastructure. Then the developers and the users would be able to deploy that project. Okay. After the project, the hardware will be useless. Okay. Now, in that term, your organization is your had expenses too much money. Now, in cloud, there's no need to expand on infrastructure. Okay. You need to focus only on your business continuity, your business. So just focus on your program, your project. No need to focus on your infrastructure. Just go and buy your infrastructure or rent your infrastructure from your cloud provider. Just complete your project, and then anytime you can leave your, or you can delete your resources, which is on rent. Now that is called OPEX, operational expenditure. You can create any resource anywhere in the globe within a minute. So even if you are in India, in US, in UK, in UAE, so wherever you are, so you can create resource all over the globe. Okay, within a minute. Now, no need to guess about your capacity. You can create your resources. You can easily scale up and scale down as per your demand grows. You can grow your resource. You can change the size of your resource anytime. You can change the size. Okay, and it will not affect your current application, current program. Okay, so without affecting your program or your services, you can easily change the size of your resources. You can easily change the number of systems. I hope you all are aware about scaling. What is scaling basically? So scaling means we have two kinds of scaling in our cloud computing terms. One is known as horizontal scaling, and another one is vertical scaling. So horizontal scaling means we are going to add VMs. So if you are getting load on your server, so rather than adding more resources in your server like RAM, rather than expanding RAM, CPU, or hard disk or network card, what you will do, you will add more VMs, more servers in your pool, so that the load will be balanced on those resources. Okay, that is called horizontal scaling. Vertical scaling means you're going to add resources in your existing server. So you're going to add RAM, you are going to add CPU. So if you are going to add individual resource in your hardware, let's talk about production environment. So this will impact your business application also, just because there will be a downtime. Just because whenever you are going to use add any resource, any hardware in your server, or you have to power of your hardware, and then you will be able to add your resources. But in cloud, anytime you can easily add your VMs. You can use auto scaling, you can use manual scaling, you can use scaling policies. On the behalf of your scaling policies, you can add and remove resources in your scaling group. So that is very easy in terms of cloud. So manageability is easy. You can increase performance anytime of your resources by adding the more NICs, more IOPS, okay, using by EBS volumes. So these are the services which basically which we are using into AWS. And at end of the session, I will show you a basic architecture also. So how to design a basic architecture in AWS so that you would be able to understand the concept of architecting. Now, the architect who are going to design their environment, who are going to design a plan for a blueprint for organization. Okay, so there is a fundamental thing, there is a foundational thing which they need to take care. So, which is known as well architected framework. So, we have five pillars in well architected framework. One is security, another one is reliability, cost optimization, performance efficiency, and optimal resource excellence, operational excellence. So, we will discuss one by one all these aspects. So, first of all, security. Now, when we are going to discuss about security, so there is a responsibility model in AWS. So which defines the layer of manageability, layer of security, which will be taken care by AWS or which will be taken care by customer or you can say consumer. Okay, so let me show you my PowerPoint, so then you would be able to understand. Now, let's suppose that is AWS platform. So in AWS platform, there are two models, which is known as shared responsibility model. One is managed by customer and another one is managed by AWS. So AWS will manage compute, storage, database. These all are the foundational services and networking. So these are foundational services and also global infrastructure, which is provided by AWS, like regions, availability zones, and edge locations. So AWS will manage all these aspects like compute resources, storage resources, databases, networking, regions, availability zones, and edge locations. So AWS is responsible to manage the security of all these services as well as global infrastructure. Now, what customer will manage? Customer will manage platform, application, which customer will install on their infrastructure, and identity and access management, operating systems, network and firewall. Network and firewall configuration will be managed by customer, and client side encryption, server side encryption will be taken care by customer, as well as network traffic protection. So these are the security aspects which will be taken care by customer, and these are the resources and global infrastructure which will be taken care of. The security of these resources will be taken care by AWS. So that we need to understand before going to design any architecture. So here on security pillar, there are few terms which we need to take care, like identity foundation, enable traceability, the resources which you are considering, you need to trace those resources, you need to trail those resources, okay, you need to monitor those resources, security at all layers, the layers which we are discussing, like a customer layer and the AWS layer. So we need to enable security on all layers, risk assessment and mitigation strategies. If there would be any risk, how we will mitigate those kind of risks. So that we need to understand, and then we need to plan our design as per the well architected framework. Next is reliability. So the resources which we are going to host on cloud service, they are going to meet with the demand. So if the service will be increased, the traffic will increase or decrease. So as per the increase or decrease, they will automatically scale up or scale down. That uh, we will check into. That is come into reliability section. Okay, and if there would be any failures, service failure will be happen. So it will recover quickly. How it will recover quickly? Okay, if there would be how you will reduce the disruption of services. So the misconfiguration and transient network issues. So all this comes into reliability section. So what you want to give a reliable solution to your organization. Okay, so through high availability to mis to mitigating the misconfiguration and the transient network issues. So after considering all these aspects, you would be able to give a reliable solution to your organization. Next pillar is cost optimization. Let's suppose you have deployed resources, few of resources into your project. Now you are monitoring your resources, and you're getting like a few of resources you are not using, and still you are paying for those resources. Let's suppose you have deployed 5 VMs which is behind a load balancer. So and your capacity, you are not using all the VMs. Okay, you're monitoring all these resources, inventory analysis, like you are not using all the resources. So what you will do, you can measure that efficiency of your resources, and then you can do anytime you can reduce the number of services or the resources anytime. And again, if your traffic increase, if there would be any spike in your application, so you can increase anytime. You can increase the number of anytime. So you can manage your cost optimization through auto scaling is the best part. You can use auto scaling, you can use load balancers. Okay, you can use cloud trail to monitor the resources. You can use a trusted advisor also. There is a tool in AWS which is known as AWS Trusted Advisor, so which will advise you on the terms in the terms of performance, cost, and and operational excellence. So and security also. So it's like a consultant. So we give you advisory about your resources which is configured inside your portal. Last one is operational excellence. So whatever resources you are going to deploy in your project, in your portal for your organization, rather than deploying those resources manually, so plan automation to deploy all the resources. So you can or it will be a reusable code, so that you can, if you want to reuse or create that same environment, so you can reuse that code and you can automate your environment quickly. If there would be any changes, you can update those changes through automation. So that is coming to operational excellence. How you will operate your environment, okay, how you will design. So rather than going manually, just go with the automation. So in AWS, we have AWS Cloud Formation, a tool which you can use where you can run your YAML or JSON script. So through those scripts, you can create your automation script. You can create your environment. You can update your environment. So it's like a blue-green deployment which you can do through AWS Cloud Formation. Performance efficiency. That is the last one. So the resources which you are using nowadays, if you see, so as day-to-day basis, technique is going to be changed. Okay, so as per your project, but you need the best solution, best resource for yourself, so that you will get into you need to take care of the performance of the resources, or whatever resource, whatever service you are going to use in the cloud. So you need to ensure your organization that the resource which you are using is good and is best for your application. Now let's come to AWS data centers. So AWS services are spread into regions. So now in these regions we have data centers. So whenever you will go to the portal, you will get regions basically. So right now we have 22 regions all over the globe. Okay. So in those regions we have data centers. So they are known as availability zones. So in each region you will get availability zones. So which are separated data centers, and they all are connected with high private link. So these data centers are known as AWS availability zone, and in and these availability zones are reside in a region, AWS region. So you can see this picture where you can see the globe, the regions as well as the availability zones. So these are the regions all over the globe, and we have edge locations also. Now, what is edge locations? So let me give you an example for edge locations, so you would be able to understand edge locations. Now, let's suppose my web application is hosted into US East, or some static content of my web application is stored into S3 in US East. Okay. Now, the users who are accessing my web application, they are accessing my web application from the globe. So the user who is in India, or who is in UAE, or the user who is in Sri Lanka or South Africa. Okay, so the users who are in US. So the user who is in US, if he is going to access my application, he will not get any latency issue. Okay, but the users who are accessing my application from South Africa, from UAE, from India, they will get some latency issue. Okay, now what I want performance. Okay, so for as in terms of performance, what I can do, I can use a service which is known as CDN in AWS, Content Delivery Network. Okay, so what you can do, you can use CDN, and through CDN you will deploy your web application or your static content through your S3. So the users will access your CDN. What CDN will do, CDN will use edge locations. So there would be a edge server which will be placed on your client side. What it will do, it will cache all the information from the server to edge server as locations basically. Okay, so if your content is stored on S3, so your content will be cached on as location, and then the users who are accessing your content or your services, they will be get that answer from edge server. Okay, and there would be a TTL which you will configure. When you will configure CTL, you will configure TTL also, so it will be removed after this TTL value. Okay, so these edge servers are based on edge location. Okay, so that is known as edge location to cache the content of your server, which is placed on somewhere in the globe. Okay, so these are known as edge locations. So these are the edge locations you can see all over the globe, which AWS is using right now. So if you want to cache your information at your client side, you can use as your AWS CDN. Now, IAM. We are going to move for IAM section, which is the most important part in AWS in terms of security aspect. Okay, when you are going to secure your environment, if it's a shared account, okay, and there are multiple users who are going to access your license, okay, your portal, your account. So at that time, this is the most secure. And again, in terms of policies, in terms of permissions, so you can manage all these aspects through IAM, identity and access management, or in terms of cloud identities also. So how it works, I'm going to open my PowerPoint. So you can configure user here. You can manage user. You can manage groups. You can create policies. You can create permissions. So now, whenever you will create an account on AWS, let's suppose that is your AWS portal. So the account email ID which is used by you for creating this AWS portal, that is known as the root account. So now AWS requires, rather than using your root account, use just go and create a user and give a permission. Which permission? Admin permission. Give a admin permission to that user. Okay, so he would be admin. He can do anything inside your AWS portal with admin permission. Okay, and remove all credentials of root. So why it is required? Just because if your root credentials are compromised, that means your all portal is compromised. So the hacker can do anything inside your portal. Now, if your admin user got compromised, you have chance to recover your all the services through your root account. So you can restrict someone to access your services through your root account. Okay. So rather than using root account, just go and create a normal user and then assign a permission, admin permission to that user, and then this you can use this user as the admin for your task, for your services. Now you can create policies also. There is one more term which is known as roles in AWS. So all these things you can configure through IAM, identity and access management. You can create users, you can create groups. Now why group is required? So group is required for let's suppose you have 1, 2, 3, 4 users who need same kind of permission. So rather than assigning individual permission to all users, do one thing, just create a group, assign that permission to group, and then add those users in this group. So they all will follow the same permission. The permission will be inherent to all users. So for manageability purpose, you can create group and then you can add your users in the group and assign permission and policies to your group. So user will follow automatically all these permissions. Let's suppose like there are 5 users who need access to EC2 instances. Now EC2 instances means VMs, virtual machines. Okay, so they need access to EC2 instances services. Okay, what you will do, you can create 5 users and individually you can add that permission to all users. Now, or or you can create a group. You can add those users into group and this permission you can assign to that group. And later you can remove the user who don't need that permission. And it is recommended to give least permission to your user. No need to give high permission. Okay, give least permission to your user so that he can do the task which is required to for them. Then we have policies. Now, what is policies? Permission means the resources, what kind of action user can perform. Like he can access EC2, that is a permission. He can access S3, that is a permission. He can access DynamoDB. He can access AWS Lambda functioning, auto scaling. So all these comes into permission section. Now, what is policy? Policy means, let me remove this. Policy means, let's suppose now that user have permission to access EC2. He can access EC2 instances. Now he has permission to access EC2 instance, but what I want to limit the actions which he can do to my EC2 instances. So that I can configure into policies. That means customize permissions or you customize actions you can say. So that I can configure into policy. So what I want like he can start and stop my EC2 instances. He can do only this permission. He can only do that action. He can perform only that action. So that I will configure into policy. And then this policy I will attach to that user. That is called policy. Okay. I hope You all are getting this policy section. Then we have roles. Now, what is roles? Roles means, let's suppose these are the services like EC2, S3, DynamoDB, RDS, Lambda functioning. I'm taking a few examples. Now, what you need the user who is managing EC2. Okay, he can access S3 also. So for accessing S3, there should be a role. Okay, that role you will assign to EC2 that he can access S3. So what you will do, you will create a role. Okay, you will create that role for EC2, and what you will specify that EC2 can manage S3 with full access or whatever permission you want to assign. So now, rather than assigning this permission to a user, you are assigning this permission to a service. So the user who is accessing EC2, he can access S3 also with full permission. So he can access his bucket, he can upload, he can download, he can manage, he can create bucket, he can delete bucket. So he will do anything. He can do anything inside that EC2 instance. Okay. So for integrating your all services or for giving a permission, let's suppose like there's a script, there's a automation, or there's a program written into my Lambda functioning. So what is Lambda functioning? It's a PaaS solution. I hope you all are aware about like there are three layers in cloud: infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service means like VM, virtual machines. They comes into infrastructure as a service. So whatever infrastructure you need, like CPU, RAM, HDD, hard disk, IOPS. Okay, so you will get your VM as per your requirement. So you will specify your requirement and you will get a VM as per your requirement. Now you have to manage your VM, which is given by AWS. Okay, so the infrastructure is given to you by AWS. Now you need to manage your VM inside your OS. So whatever application you are going to install, whatever services you are going to configure inside your VM, you will be responsible for security, for update, for patching, for managing all the or monitoring all the services inside your VM. So that comes into infrastructure as a service. Now platform as a service. So platform as a service means like what I need to deploy my code on Linux or on Windows platform or on Docker container. Okay. So what I need platform only. I need Linux platform. If I need to run that .NET application, so what I need a Windows platform. Okay. Or I need to run a container. So what I need a Docker. Okay. So I need a platform basically. So I'm not looking for underlying hardware. I need a platform. So at that time, I will choose platform as a service. So I will choose Linux or Windows only. I will choose only the platform, which platform I need. So I will choose Linux. So AWS will give me a Linux platform, Linux-based platform where I can run my codes. So I can run my application on PHP, Java. So whatever code I want to run, I will run my code on my platform. So what AWS is using in terms of hardware, in terms of infrastructure, okay, I will not aware about that part. I will get only the platform that is come in the platform as a service. So Lambda function is come in the PaaS. It's a PaaS solution in AWS, platform as a service. Software as a service. Software as a service means you are not going to manage anything. You are not going to manage infrastructure. You are not going to manage platform. You will use only service. Your software as a service like Office 365, CRM, okay, Salesforce. So they all are software as a service. So you will only purchase the service and you will use the service. And all aspects will be managed by service provider. So I'm coming back to my use case, my example. So let's suppose there's a lambda functioning. Okay. So what I want like if anyone, any user is going to access what is S3? S3 is a simple storage service. Okay, which user can access through internet and they can upload and download their content in S3. So now that is my shared S3 bucket. Okay, so bucket is like a container where you will upload your data. So now from Grow, users are accessing my bucket and they are uploading and downloading data. What I want some trigger. I want some monitoring. Okay. So if anyone is going to download something from my bucket, okay, so there should be a trigger. Okay, that means some background processing through a script. Okay, and I will get a notification like this user is downloading that content from my bucket. Okay, so for that purpose, what I will do, I will write a script into lambda functioning, and then I need a access of S3 on lambda functioning. Now for accessing S3 to lambda functioning, what I need a role. So I will configure a role for lambda functioning to access S3. Okay, I will configure this role. I will apply this role to my lambda function, and then lambda function would be able to trigger whatever code I will write. Okay, so that thing you can do through roles. Let's come back to our slides. So the main account is root account, okay, which have extreme power and cannot be limited. That means he can do anything. So now, what is the safe way to administrate your portal? Create a IAM admin user, lock away the root credentials. So just lock your credentials, root credentials. Do not expose those credentials to anyone. Use as IAM admin user for your operational task, for your administration task. You can create your users. You can manage your identity access management through portal, through CLI, through SDKs. Okay, so you can integrate your all other services, AWS services. You can federate your identity management. So let's suppose there is a cloud application which is launched on your AWS portal. So the users who are accessing, the external user who are accessing those applications, how they will authenticate themselves. So for those kind of users who are coming from the globe, who are not part of your organization, so for authentication purpose, they will use the federated authentication. Like they can authenticate themselves by their Instagram account, their Twitter account, their Facebook ID, their Gmail ID. You can secure your application through IAM. You can assign granular permission. So whatever permission you need, you can manage permissions through IAM. So more granularly, you can manage your resources, your services, your portal through IAM principle. So IAM user, federated user, IAM roles, and identity providers. So identity providers are basically who are providing services to AWS. Like there is a compute resource, so there would be a compute provider. So there is a storage resource, so there would be a storage provider. So similar like that, the resources which are services which you are getting into AWS, all these services are provided by a identity provider. Now that is a basic fundamental of IAM. I'm going to discuss about VPC. Now that is the most important topic in AWS. Why it was important? Just because whenever you are going to deploy your resources in AWS, what you need a VPC, a virtual private cloud, similar like your on-premise infrastructure. I'm going to again my PowerPoint. Let's compare with like our on-premise environment. So similar like our on-premise, in our on-premise, if we need to set up a data center, let's take an example. So first of all, we'll set up our network infrastructure. So let's suppose in my network infrastructure, that is my network 192.168.0.0/16. That is my network. Now, as per my department, I'm using subnetted addresses. So I'm using 4 subnets for my organization. So let's suppose 192.168.1.0.0/24/24. 3.0/24, 4.0/24. Okay, and then I will deploy my servers inside these subnets. Correct. So similar like that on AWS, if you are using AWS cloud, so similar like your on-premise infrastructure, first of all you need to create a VPC, a virtual private cloud. Then you will specify your network address, uh, 0.0. I'm taking the same example, and then you will specify your subnets. So subnet would be this subnet would be front end for me, and this would be back end for me. So addresses would be 192.168 uh, 0.0/24 for my front end server, and 192.168 1.0/24 for my backend server. Then I will place my EC2 instances inside that server. Okay, now in your VPC, whenever you are going to configure your VPC, so basically you are securing your environment through VPC. That is also comes into security aspect. So you can create your environment more secure, okay, through your VPC. So in front end, you will place the servers which will be exposed to internet. In back end, you will place the servers which will not going to be exposed to or to internet, like your DB servers, like your uh, RDS instances. So these you will place into backend server. Okay, and then the communication between front end and backend you will manage through security group, which is a firewall kind of firewall. Okay, so we have two kinds of firewall in AWS. One is NACL, and one is SG, security group. So security group applies on EC2 instances. So whatever traffic coming to your EC2 instances, you will manage those traffic through security group. Now NACL, NACL will be applied on your subnet level. So incoming and outgoing traffic you can manage through NACL. So you have two layers of security. One is security group and second one is NACL. So you can manage your traffic through NACL or through security group. So your front end and your back end will communicate through security group, and then for accessing those servers on internet, what you need internet gateway. That internet gateway, in that internet gateway, there would be a route. So the users who are coming from networking background, they will understand that concept very easily. So there would be a route for internet, which would be this uh, value, which is a wildcard basically. So 0.0.0, that means any traffic which is coming to my EC2 instances will be allowed through a internet gateway. Correct. So these VMs will be this VM will be accessed to internet, and internet will be available to those VMs, which is in front end. Okay, and that internet gateway you will apply to your front end subnet. All these tasks you will do manually, or you can create a automation script. So you can create a JSON script. You can use a YAML script. Okay, and through that script you can automate your environment, or manually you can specify that which subnet will use internet, and later you can use NAT gateway for your private subnet. Now if you need internet access on your private subnet, you can use NAT gateway. So it's a very wide topic, so we are not able to cover all these things. I'm giving you a basic idea about the VPC. There are lots of things which you can do, uh, like you can create multiple VPCs in your AWS, then which are isolated with each other. Let's suppose like 192.168 16.0/24 and 20.0.0.0/16. So they both are using different address as well as they are different VPCs. Okay. Now what you need communication between these VPCs. So you can enable VPC peering also. Okay. So the resources which will be in these VPCs, they will communicate with each other. Okay. That you will enable through VPC peering. Now, next service is known as VPN. You can configure VPN if you need a hybrid connectivity from your VPC to your on-prem servers. So what you need uh, AWS Direct Connect, which you can use, which is which will give you a private connection from your on-prem to your AWS environment, or you can use VPN, a site-to-site VPN. Okay, so through that you would be able to access your resources from on-premise, or your resources from on-premise will be connected. They will be connected on AWS resources. So use case would be like if your DB is placed into your on-premise and your web application is configured into AWS. So you want to connect your DB with your web application. At that time, you need hybrid connectivity. Okay, so for hybrid connectivity, what you will do, you will use VPN. So that you will configure through VPC section, and you can create multiple tunnels. You can enable NAT gateway. So all these things will become in VPC section. So VPC is a virtual network dedicated to your AWS account. Exists either in IPv4 or IPv6. So you can choose your range. Enable you to create specific slider range. So you can choose your specific slider range. If you are not if you are not from infrastructure background, you are a developer. There's no need to worry just because AWS is giving you a default VPC. So there would be a default VPC, which is automatically created by AWS for those users who don't know how to create VPCs, what are CIDRs, and how to design the network path. Okay, so for them, for those kind of users, for those kind of engineers, there is a default VPC which you can use for your development and testing environment for your project. Okay, so provide strict access rule for inbound and outbound traffic. You can manage your inbound and outbound traffic through NACLs. You can design your VPC like availability zone A, B, and C. Now, let's suppose for high availability aspect, let's suppose that is my reason, AWS reason. Inside that reason, that is my VPC. Now, inside my VPC, what I need a high availability solution. So what I will do, I will create my subnet. So if you remember, in each region there are multiple availability zones. Okay, so rather than creating your subnets in one availability zone, just create your subnet in multiple availability zone. So that if your one data center goes down, still you can access your resources from your different data center. So that is also come into architecting. Just because you are designing a best solution for your organization, so you need to take care the resources, the web application which you are placing into a VPC should be available 24/7. Should be highly available. Okay, so that is called reason, then VPC and subnet. So let's suppose that is your public subnet. So already zones comes in like 1A. So your first public subnet is placed into 1A availability zone. Then second one is 1B, sorry, 1B. Then your private subnet. So that is placed into 1C. Then next private subnet that is placed into 1D. Correct. So if you are designing a three-tier architecture, so there would be a public subnet, then there would be a app subnet, there would be a DB subnet. Okay. So the private would be DB subnet, then there would be a app subnet. So they all are interconnected through SZ rules, security group rules. So that is highly available design for three-tier architecture, web application architecture. Okay, what you will do, you will use auto scaling for your VMs which are placed here. Okay, you will use load balancers, balancing your load in different availability zones. There would be a route 53, a DNS, which you will use to route your traffic to your load balancer. Okay, there would be a S3 bucket, which will host your static content of your web application. Okay, there would be a CDN. Okay, and then users who are accessing your application, so their request will be forwarded to Route 53. Then Route 53 will be forward this request to Load Balancer. Load Balancer will decide where to forward this request as per the configuration done into your load balancer. Okay, and auto scaling will take care load on your VMs and the traffic. So the number of VM which is required to handling the traffic, your auto scaling group will decide that. So it will automatically increase or decrease number of instances, number of VMs inside your availability zones. Okay, in DB there would be a master DB, there would be a replica DB. So if your master DB availability zone goes down, still you can access, user can access their data through replica DB. You can use Memcache also. You can use EFS also, Amazon EFS, Elastic File System, so which will be associated with your all EC2 instances. So they can store your data of EC2 instance will be stored in a central location. So that is a basic architecture of a three-tier application architecture on AWS. I hope that is clear to all of you. So you can create your subnet in different availability zone for high availability aspects. So I hope guys you all are enjoying this webinar. Now I'm done with my this webinar.
Thank you so much. It has been a great session. I see a lot of you are still asking if you will get the recording of the session. Yes, you will. You'll have to allow us some time, and we shall help you with the links on your email addresses that you have registered with. Alternately, you can also come back to the website, and you'll be able to get the recording from there. So yeah, that's the way out. Plus, you'll be getting the certificate as well within 2 to 3 business days. So please allow us that time, and we will be getting back to you with all the required details. I see there are a couple of you who are still posting questions. You can, in case you are wanting to know more about and learn more about the overall topic, the portfolio reflecting or flashing in front of your screens is what we can help you with, and there can be a full-fledged training on each of the topics that's mentioned here. And we have a great pool of trainers, which I've already mentioned about, and we can actually conduct a specific training for you guys if the need be. Please drop in your queries in the survey form that you'll receive post this session, and do share your inputs and feedbacks as well. So yeah, we'll get back to you with the recordings. Plus, you can reach out to your L&D spocs and teams internally in case you want training to be done for your teams. So yeah, thank you so much, everybody. Please take care. Have a good evening, and stay safe, stay indoors. Bye-bye.